Chapter 9, Lesson 2, Simplifying Square Roots. Today we're going to simplify radical expressions using two new properties, the product property and the quotient property. So the product property, it tells us that the square root of AB, it equals the square root of A times the square root of B. And we also can see that the quotient property, which tells us that the square root of A over B equals the square root of A over the square root of B. You can use the product property of square roots to simplify radical expressions. What we need to know about radical expressions is that they need to be in simplest form. For a radical expression to be in simplest form, there can be no factor of the expression under the radical sign that has any perfect square factor other than 1. And there are no fractions under the radical sign, and no radical sign in the denominator of any fraction. Here's our first example. We're going to simplify the radical expression, the square root of 180. Now, I cannot think of a number that is the square root of 180. So we're just going to simplify it. We're going to think to ourselves what the greatest perfect square factor is that can go into 180. I can think of 36 times 5. 36 is the greatest perfect square that can go into 180. Now I can use the product property of square roots. This means that we can take the square root of 36 and multiply it by the square root of 5. Well, we know that the square root of 36 is 6, and then we can just bring down our square root 5. And we've simplified our expression. Let's go back, though, to the beginning. I chose to use the numbers 36 and 5 as the factors of 180, but what if you didn't know just off the top of your head that 36 times 5 would give you 180? Let's start off smaller. Let's just use a smaller perfect square, like 4. Four times 45 is going to give us 180. Four is a perfect square. So this just tells us that we can use the square root of 4 times the square root of 45. Well, the square root of 4 is 2. And the square root of 45, we can just bring that down. Now let's try to think of two factors of 45 that we can simplify. Well, I can think of the numbers 9 times 5. Let's use those two. Using the product property, I know that the square root of 9 times the square root of 5 is the same thing. The square root of 9 is 3. And 3 times 2 is 6. So even though we didn't start off with 36 times 5, we started off with smaller factors, you still end up getting the same answer. Example 2. Simplify a variable expression. So again, we're going to factor using the greatest perfect square factor. Here's example 2. I wrote it wrong. So we have the square root of 24s squared. So I'm going to factor using the greatest perfect square factors, and I'm going to use the square root of 4 times the square root of 6 times the square root of s squared. Well, I know that the square root of 4 is 2. I don't think that 6 is a perfect square. Just bring it down. And just like we learned last week, the square root and a square cancel each other out. So we're just left with s. There are no perfect square factors in 6, so I'm left with 2s times the square root of 6 as my answer. Now we're going to use the quotient property of square roots. The square root of 13 over 36. This is the same thing as having the square root of 13 over the square root of 36. Look at your numerator, the square root of 13. Do you know any perfect squares that are factors of 13? The only factors for 13 are 13 and 1. So we'll just leave this as the square root of 13. The square root of 36, though, is 6. So we have simplified the radical expression. You try. Simplify the expression. Press pause. When you're ready to begin, press play. Check your answers. If you missed one of these problems, go back and look at examples 1, 2, or 3.